Okay, moving right along to the O in solid, the open-closed principle. The statement of the principle is easy. Classes should be open for extension but closed against source modification. And as with all of these, it's much easier to see when you show an example. Here's an example of a report class that when you're trying to actually generate the report, it checks what the report format is and does something different depending on the format. What this means, you can tell immediately, is suppose that I now define a new report class, PostScript formatter, for example. It's obvious that I'm going to have to make a change in this output report method of the superclass just to add this new capability. So that's a clear example of violating OCP, because I'm not trying to change any original behaviors. I'm just trying to add on some new behaviors, yet I can't do that without making changes to the original class, right, that has dependencies on all of these other classes. So in this case, now, you could argue that in a statically typed language, this is much worse. And it's worth keeping in mind that all of the solid principles, when it comes to the cost of minimizing change, there's really two kinds of costs. One of them is sort of a cognitive cost. How hard is it for a programmer to understand what is necessary in order to isolate a change? The other cost is just like a grunt work cost. So if this was a statically typed language, and this report class is a superclass that's been compiled, there's probably all kinds of other classes that have a dependency on it. So anytime I change the report class, I'm going to have to recompile all those other classes as well. And that's particularly painful if the only thing I'm doing in the report class is adding another clause here to add functionality as opposed to changing anything that was working before. So that's the problem OCP tries to solve. And the picture of a nose, if you can tell that that's what it is an indicator of a design smell. The design smell here is basically when you have a case statement. 9 times out of 10, a case statement is not what you wanted. And sometimes what you're using it to do is hide the fact that there's a place where you could have an extension point, but you've ruined the extension point because the only way to extend is adding more stuff in the case statement. So this is not the only symptom of OCP violation, but it's a pretty prevalent one. So what can we do about that? This is one of the places where a design pattern can help us. The abstract factory pattern is a way of creating something whose type isn't known until runtime. So the problem we had in this example is basically that at runtime, we need to look at this format variable, and depending on its value, which we won't know until runtime, that determines which of these other classes we're going to instantiate. The abstract factory pattern helps to solve this, and because Ruby has metaprogramming, it has a particularly nice, in my opinion, implementation of this pattern, which I hope I can show you without, let's see. So here's a version of the report superclass that avoids the OCP problem. That's the version we had before. All I've done is change it so that I'm assigning a formatter variable based on the value of the format instance variable. So this still has the problem that I would have to add clauses to this case statement if I wanted to add a new formatter type. Here's another way to do it. I could look at the value of format, and don't be thrown by this. It's a little bit of shorthand. But what it's saying is, look up this thing and see if it's the name of some class. That's all it's saying, right? So if I can arrange for format to have values like PDF or HTML, then all I'll do is convert that into a string. Classify will make it go to camel case because classes have to have uppercase names in Ruby. Constantize will look it up and convert a string representing a class name into an object representing that class. And if there is no such class, then I can rescue the name error and say, you specified a formatter that doesn't exist. But with this code, I can now just add more formatter classes, and as long as for any possible value of format, I have a corresponding class name, then this will just work, right? I've now removed the need to make any changes to this output method when the only thing I'm trying to do is extend its behavior by adding other variants to it. This is a particularly nice solution to this problem that dynamic languages with metaprogramming have and static languages don't. In static languages, there's an elaboration in the book that explains this, but you basically have to do an abstract constructor that makes an end run around the type system to make this work. And it's kind of ugly. And that's why the abstract factory pattern is prevalent in statically typed languages, because you need special syntax, essentially, to solve this problem. So what other things can we do to sort of help ourselves be more compliant with open-close principle? Well, if the example we just showed of generating a report with different output formats is actually a special case of another design pattern, which is there's kind of a general task you want to do, and the task has many different ways you could do it, but there are similarities that you could capture across all those different ways. And there's at least two flavors of how you might want to do that. The template method design pattern helps you when you have the same set of steps no matter what the variant is, but the implementation of each step is different. And in this case, because the set of steps is the same, you can imagine having a superclass where the high-level method is step 1, step 2, step 3, and then each of the subclasses would just override how those steps are done. So in that case, it's appropriate to use inheritance. And we'll show an example of this in a moment. So here's how this looks in boxes and arrows. We have some abstract class that has an overarching template method that just does a sequence of operations. And Ruby doesn't have truly abstract classes, but in a language that did have them, you would have a concrete class that implements the template method, and then you would have subclasses that override each of the operations to do whatever's important for that subclass. So in terms of our report, we'll show an example in a minute, but you can imagine having like a header, a body, and a footer. All reports have to have those, but the way you generate them would be different depending on what the format is. The other thing you can do is you can use a strategy, which is the task is the same, and therefore the high-level interface between the rest of the application and that task can be captured, but all of the ways that you could do the task are actually quite different. And in this case, inheritance doesn't work, or it doesn't work gracefully, because there isn't very much behavior that you can reuse, right? All we're saying is, look, the idea of producing a report is going to be the same no matter what the output is, but the specific set of steps is not even going to have the same ordering, or not even the same types of steps will be necessary depending on what the report is. So in that case, inheritance kind of gets in your way, and this is where we use, again, composition and maybe some delegation. So in this case, we have an overall strategy, and the strategy really just exports one high-level operation. You might have subclasses of the strategy that override the operation at that level. So let's see what this might look like in code. On the top, this is a version of using the template design pattern. We've got a top-level method called output report, and the set of steps is the same no matter what. So all we really need to do is for each type of report, we'll just override these instance methods to do whatever makes more sense for that type. So what we don't get to control is the fact that these are executed in this order and without any intervening steps, right? As long as all of our variants are able to sort of conform to that part of the template, this is a perfectly reasonable way to do it, and we can use just plain old inheritance to say, we're all going to inherit from report, but we'll override selectively the methods that have to be different for this variant. So in terms of our, if we were drawing a class diagram, we've got the report superclass, we've got HTML, and whoops, that should be a PDF report. I suppose I could change that. There we go. We've got the overall superclass. We've got two subclasses that inherit from it. The methods that are sort of in light gray and italics are, in a programming language that had fully abstract classes and methods, these would be virtual methods. They'd be purely abstract. You have to override them. In Ruby, there isn't really a notion of a purely abstract method. You could make one by defining methods up here that raise an exception. So if you don't override them, what will happen is you get an exception. But I think that's a little hacky. Okay, so this is pretty straightforward. If we're going to use strategy, how would it look different? Well, in this case, what we're saying is the idea of having a report and being able to output it, that's a high-level thing. We should just be able to capture that. And report basically has a bunch of other behaviors too. But as far as output, all we're going to really do is delegate generating the output to one of the subclasses that does it. So we're still using inheritance here, but the inheritance is much more coarse-grained, right? We're really just overriding the entire output report method, because the idea is these are different enough from each other that there isn't really a win in inheriting the behavior from a common ancestral class. So in this case, we just say that the report class, the superclass, has an attribute, which is which formatter to use. And whenever you call output report, all you're really doing is, this is a classic delegation, right? I have a method with a certain name, and the only thing it does is call that exact same method, but in one of my subclasses, right? So this is delegation the hard way. And as you might imagine, if this use of delegation is so popular, shouldn't there be a way to support it with less text? And actually there is. I'll show it in a moment. But before I show the example, let me motivate it with one more piece. The last case where open-close principle is very easy to run amok of is if you have extension points that end up not being independent of each other. So going back to the report example, we have a report formatter. We have these HTML and PDF subclasses. But it turns out that in PDF, there's other things you can do with the output file. Like you can add a password so that somebody who knows the password can read the file. You can add a watermark so that it says draft or do not duplicate. And the problem is, if you can add these behaviors selectively, then you're stuck, if you're trying to use inheritance, you're basically stuck with coming up with all of the permutations of them that you would want and coming up with a subclass per set of permutations, right? That's hardly dry. So the decorator pattern can help us here, and you've actually already seen it in the wild. You've seen it in active record scopes with things like movie for kids with good reviews, when we're stacking together different behaviors, and each one returns something that the previous one can operate on. So for the report example, here's how you might do it. We have a basic PDF formatter, and we can subclass PDF with watermark or PDF with password, but in any of the subclasses, they'll keep track of the base object, the base PDF formatter object, and they can delegate the output routine back to that. So when I call the PDF with watermark formatter, it will delegate a call to output to the original class, because it doesn't do anything differently in terms of output, but then it does more stuff. It adds a watermark on top of the output, right? So these are cases where the subclasses are selectively adding on behaviors, and you can actually combine multiple subclasses, kind of like we did with active record scopes down here, but you do it in a way that avoids this explosion problem. So yet another example of composition over inheritance. So in practice, how do you know where you might be violating OCP? Because part of the premise of Agile is you don't know in advance all of the places in which your app might change. And that means you have to choose, right? As you're designing your app, you might have to sort of speculate on which places you might want to extend, and you're not always going to get it right. So the important thing is the earlier you can expose those changes through talking to the customer and figuring out which scenarios are going to cause you to have to evolve your app in this direction, that's kind of how you figure out where the pain points are going to be. Right? So the techniques that you already know are actually designed exactly for this, but one of the sort of caveats of OCP is you don't always know until it comes time to maintenance and improving the product. You don't really know which extension points you're actually going to care about. So you sometimes have to make an educated guess. Then you can try to close against the types of changes that you think are actually not really extension points. Right? So in Rotten Potatoes, if we decided that in addition to handling movies, we also want to be able to handle public demonstrations or something like that, right? Things that really don't have as much in common with a movie as they are different, you might close against that type of change. You might deliberately make it so that that type of change is painful, because it's a way of sending a signal that the idea of a movie and the things about movie is so woven into your application that that's not a place that an extension makes sense. So here's an example to see if you can kind of apply this to a piece of software that many of you have seen and that we talked about when we did third-party authentication. We talked about OmniAuth. OmniAuth, as we saw, defines a small number of RESTful endpoints, routes in your application that you have to provide that handle the results of authentication with a variety of third parties. So there was a failure hook, there was a success hook. And when you add a new auth provider, as you saw, there's all these gems that implement authentication to work with different providers kind of alongside the basic OmniAuth gem. So the question is, which statement is false regarding OmniAuth and how it relates to the design patterns that we've seen so far? OmniAuth is compliant with the open-close principle in the way that it is designed. OmniAuth helps your app follow the open-close principle if you use it correctly, at least as far as doing authentication. OmniAuth is an example of the template pattern in the wild, and OmniAuth is an example of the strategy pattern in the wild. So which is false?